Welcome to the Explainer. We are constantly surrounded by these vast, complex systems that we honestly rarely stop to think about. They are completely invisible to us, yet they dictate literally everything, from the very environment we inhabit right down to the glowing screens we interact with every single day. Today, we're going to explore that hidden infrastructure.
To kick things off, let me start by asking you a bit of a provocative question. What exactly is a SIP? Like SIP. When you hear that acronym, what actually comes to mind? Is it some massive policy document sitting on a government desk somewhere? Or is it a stream of data zooming through a fiber optic table? I'll let you think about it for just a second, because the truth is actually pretty fascinating.
Well, here's the twist. That one simple three-letter acronym secretly runs our world in two entirely distinct yet incredibly vital ways. On one side of the coin, we have state implementation plans. These are heavily regulated by the EPA to protect our physical environment. And on the flip side, we have Session Initiation Protocol, which is this foundational telecommunications technology that enables all of our digital connectivity. Basically, one gives us clear skies, and the other gives us clear video calls.
So here is our roadmap for today. Number 1, planning for clean air. 2, fixing non-attainment areas. 3, connecting the digital world. 4, the digital call setup. And finally, 2 vital invisible systems.
Okay, let's dive right into this. Section 1, planning for clean air.
To really ground this kind of abstract policy in physical reality, just picture a perfectly clear city skyline. Under the Clean Air Act, the EPA establishes what are called National Ambient Air Quality Standards, or NAQS, to protect public health. But here's the thing. They don't just wave a wand and say, make the air clean. They target 6 very specific major pollutants: ozone, particulate matter, which includes both PM 2.5 and PM 10, carbon monoxide, lead, nitrogen dioxide, and sulfur dioxide. So the whole goal of an Environmental State Implementation Plan, or SIP, is to create a highly localized strategy to ensure those specific pollutants stay well below dangerous levels in the actual air we breathe. And listen, an environmental SIP is absolutely not just some static file gathering dust in a filing cabinet somewhere. It's a continuous, living document. The EPA actually revises its standards every 5 years, which means states have to continuously monitor their air quality, develop new plans, submit them for review, and then implement them. It's an endless cycle, and it's designed that way specifically to address the highly unique local pollution problems found in different states.
Now, what's really interesting here is how perfectly divided the responsibilities are between the federal standard setters and the state-level enforcers. The federal government, through the EPA, sets the national standards and officially designates whether areas are meeting or failing those standards. But the state governments? They are the ones actually doing the heavy lifting on the ground. They operate the monitoring networks, they develop these massive emission inventories, and ultimately, they adopt the necessary emission control measures into their SIPs. The EPA is really just there to approve and enforce what the states build.
But what exactly happens when a state's air quality fails to meet those federal standards? That brings us to Section 2, fixing non-attainment areas. When an area is officially designated as non-attainment, meaning it violates the standard or contributes to a nearby violation, a really rigorous race against the clock begins. The Clean Air Act requires states to submit an attainment plan within a strict 18 to 36-month deadline, and they have to prove they'll reach attainment as expeditiously as practicable. Depending on the pollutant, this is a massive undertaking. To put it in perspective, states might have anywhere from 3 to 20 years to completely fix their ozone issues, and maybe 5 to 10 years to fix particulate matter. To pull that off, they've got to run incredibly complex air quality models, adopt reasonable new controls on pollution sources, and prove they are making measurable, reasonable progress every step of the way. And if they fail to meet these SIP deadlines, the consequences are severe. If a state drops the ball and doesn't submit a proper plan, an 18-month sanctions clock starts ticking, which triggers a harsh 2-to-1 offset penalty for any new pollution sources. If they hit the 24-month mark without fixing the issue, highway funding sanctions kick in. That means states can literally lose their federal road money. And simultaneously at that 24-month mark, the EPA steps in and initiates a federal implementation plan, which is essentially the federal government taking over the state's air quality management. So yeah, the pressure is immense. Now that we've cleared the air on environmental SIPs, let's completely switch gears and dial into our second definition. Section 3, connecting the digital world. In the telecom world, SIP stands for Session Initiation Protocol. This is an application layer text-based protocol. Its entire job, its whole reason for existing, is to initiate, maintain, and terminate real-time sessions over the internet. If you have ever made a VoIP phone call, used Skype, joined a Zoom meeting, or used a corporate unified communication system at work, you have relied on SIP. And because it's text-based, it actually works a lot like the HTTP protocol that runs your favorite websites, which makes it incredibly flexible. To make all this global communication happen, SIP uses a beautifully distributed network architecture made up of 3 main pieces. First, you've got user agents. These are the actual endpoints, like the smartphone in your pocket or a soft phone app on your laptop. Second, we have proxy servers. Think of these as the traffic cops. They are routing intermediaries that make sure your call request finds the fastest right path through the internet. And third, there are registrar servers. These maintain a constant database of user locations so that SIP can dynamically locate you and route a call directly to you no matter where you happen to be in the world.
So, how do those components actually talk to each other in real time? Let's take a look at Section 4, the digital call setup.
Let's see how this builds step by step into a structured digital handshake. The exact moment you click call, step 1 kicks off. Your user agent sends an invite request that details your media types and codecs. In step 2, the recipient system responds with a provisional message, usually a code called 180 ringing, which basically tells your computer, hey, the call is processing. Step 3 happens when the person on the other end actually answers. Their system fires back a 200 OK message. And finally, step 4, your system sends an EK, or acknowledgement message. Bam! Just like that, the connection is confirmed and your audio and video start streaming.
Now, terminating that call is just as remarkably orderly. It's not just a sudden messy dropping of a connection. It's a very polite digital conversation. When you hit end call, step 1 initiates a bye request. In step 2, the receiving party acknowledges that termination with another 200 OK message. Just like web traffic relies on standardized numerical codes, SIP relies on 100-level codes for provisional updates, 200-level codes for a successful action, and 400-level codes for errors. It's what keeps our global communications so incredibly structured and reliable.
And from a business perspective, the benefits of this structured system are a total game changer. Because SIP transmits over existing internet networks, it completely eliminates the need for companies to maintain separate, highly expensive voice and data networks. It enables something called SIP trunking, which replaces those old legacy ISDN phone lines, saving businesses an absolute fortune. On top of that, it provides dynamic user location availability. That means your work extension can ring on your laptop in a coffee shop in Tokyo just as easily as it rings on your desk phone back in New York. And it does all of this while maintaining robust authentication and security. Well, we have covered a tremendous amount of ground today, right? From the physical atmosphere we breathe to the digital stratosphere we communicate through. Let's bring this whole narrative full circle in Section 5, 2 vital invisible systems. So, the crucial takeaway here is that we live our modern lives fully supported by these two entirely different invisible SIPs. On one hand, the EPA state implementation plans are running continuously in the background, keeping state governments accountable, managing ozone levels, and quite literally protecting our physical health and the environment around us. And on the other hand, the telecom session initiation protocol is quietly routing millions of data packets across the globe, setting up these intricate digital handshakes, and enabling the modern global connectivity that allows us to work, talk, and learn together.
As we wrap up, I really want to leave you with this provocative thought. Which SIP impacts you more deeply right now? Is it the environmental plan that is giving you clean air to breathe at this very moment? Or is it the digital protocol that is allowing you to seamlessly stream this explainer? The wild truth is, we couldn't thrive in our modern world without both of them working perfectly, side by side, completely invisibly. Thank you so much for joining me to explore the fascinating dual nature of the infrastructure surrounding us.